And so our first talk is from James Noble, who'll be talking about heaps of type systems.
Something like that. I was having a discussion with my colleague Sophia, who said she wasn't happy with my talks because I make too many jokes, and it wasn't clear what the takeaways should be. So I thought I'd start this slide with the takeaways, and the takeaways here are from KFC, this idea of a heap model, which I'll talk about, which is going to sit between, what sits between the operational semantics and the memory models. I'm going to give a bit of advantages of doing that in Dafny. I'm going to reflect a little bit on Dala and Rust and the overall experience I've had with doing this. It very much is a work in progress talk, obviously, because the slides aren't finished. So, any ideas, any Rust programmers willing to admit they're Rust programmers in the house? Okay, fine. So what's the lifetime of that borrow?
I have a compiler with the borrow checking for me.
Precisely. But does this in fact even compile? Should that compile? I mean, let's just, we declare mutx and there's some box of some size, and then we're initializing it in here, and we're calling new inside, you can't see, we're calling new inside that first block, which in Rust will allocate a memory scope, and then we'll allocate the thing inside the memory scope, yeah? And then it goes away at the first closed bracket. I'll gurn at the camera. Should it compile? I mean, I think you've got two different types because you've got two different memory things there, but of course it's Rust, so it does compile. Which raises for me the question, well, why and how should we know? How should we know that that's what it's doing? Another example, I guess, somewhat related, this is the famous doubly linked list in Rust, except, of course, what's Rust famous for? Oops. What's Rust famous for? Rust is famous for the language in which you can't write, or sorry, safe Rust is the language in which you can't write doubly linked lists. Because doubly linked lists are bad. And if you talk to enough Rust programmers, they will tell you that you shouldn't want to have doubly linked lists, that wanting to have doubly linked lists means that you're morally impure. And that's my shitty thing playing up. It has worked. Sorry? Well, we're right, we had that, or not wanting to have currying as the foundational basis of your language. Precisely, well, whatever, all these things are bad, and then at some point I say, yeah, well, I just think of a doubly linked list as a, sorry, you're approaching because you need to fiddle with stuff, or as a, we're good, right, sorry, as a proxy for data structures that people actually use, like B trees, which are kind of important if you want a database, a structure you can access with indexes and also traverse, or the kind of butterfly lists and edge structures you might have in computer graphics, where you do want these nested things. And how do you do it in Rust? Oh, well, we go back to using integer indices into arrays, which is kind of like Fortran, but slower, because, as there was a good talk in the capability workshop, the big issue in the English Rust community in particular is whether we should push all those array bounds checks into hardware and do it every single time, or whether we can somehow negotiate and actually optimize some of them away. Cheers. Right, this is really not the kind of talk you should give for those of you graduate students in the room. Don't do this. That's what Sophia would want me to say anyway. Or maybe you'll remember them the talk, I don't know. This is a classic Rust error message. You tried to have a doubly linked list, you're not allowed to. I had a workshop paper that put this code in, which is kind of drawing on other work that I did 25 years ago, which says, look, you could actually have a version of Rust where maybe you have something called local ownership, where stuff can't leave a thread, but and in fact, the things in this list have to be in the list, but it's almost as if those things, if you could have, and you could set it up with unsafe Rust, a linked list, you could have it if you had multiple immutable borrows, as they're called in Rust, yeah, multiple immutable borrows. You can make a doubly linked list with that topology in unsafe Rust. You can port it into safe Rust. You just can't work with it in safe Rust because of the Rust constraints. And then I guess as a researcher, my question was, okay, well, how do I convince that someone who's now effectively working solo and trying to get contracts, if someone has a day or so a week that they want to rent my brain, it's available, come and talk to me afterwards. Luckily in New Zealand I was able to extract a research contract when I left my university, so that's sort of keeping me fed and in plane fares. What would I have to do to convince people that they should go into Rust? Oh, well, obviously what I ought to do is hack the Rust hack the Rust borrow checker. Ellen in the front row, how long have you been doing that for? You've not been doing it, that's all right, you're right. A man has been doing it. Years. Okay, or I could learn cock or lean. Cheers. Model the entire complexity of the Rust programming language. So, the first, again, one of the takeaways there is this idea of a heap model that often I think when we talk about our formal models, and this is obviously done in graphics, but for those of you who prefer LaTeX, can imagine this has been typeset in LaTeX. We have an operational semantics for our programming language on one side, and we're all quite familiar with that. And then the sort of semiconductors on the border there to represent the very low-level memory models that, again, if you worked on concurrent Java or concurrent Rust or anything, or even the Cherry stuff, you're all familiar with the rules about what happens when you have multiple CPUs accessing memory chips and all this question. Is it a weak memory model? Is it a strong memory model? Is it, logically consistent or whatever? About threads and about hardware. And, ASTs are often about types. Well, dynamic languages don't really have types, and sequential languages shouldn't really trigger these kind of low-level memory bugs. And, well, I was going to say extensible languages don't have syntax, but that's just being mean. But I think there is, for languages like Rust and a whole family of languages, I think we want something in the middle. And that something in the middle is what I'm calling the heap model. And so it's not the AST or the type system. On one side, it's not the detailed memory model about how you're actually interacting with the hardware, but it's the description of the kind of constraints I've been talking about in Rust. That's actually a picture from a dynamic or sort of dynamic/gradually typed language, a postdoc working with Tobias and I did a few years ago called Dala. We'll talk a bit about that. Effectively, it has three different kinds of objects. Local objects, which are the ones I've talked about with Rust that can't really leave a thread. It has immutable objects, the red ones, which are the things you're all familiar with from Haskell. And then it has ISOs, which are mutable objects, which can traverse threads under the sort of Rust-like condition that there is only ever one pointer into them. Okay, and the heap model is about describing that and talking about it. Let's see, why Dafny? Well, the short answer is because I had experience with Dafny. In the last course that I developed and taught was a third-year formal methods course. I've got other papers, and I'm happy to have discussions if people are doing that about my experience there, which was, well, Dafny was probably better than any of the other ways we'd tried it, but you need a lot of support. And, well, again, this is one of my favorite Dafny slides where I've written an if statement and it's complaining about that I can't assign a sequence, a set of strings to a string variable. Anyone know why? Dafny, sorry. The brackets, that's right, yes, because Dafny is really two languages. It's really the expression language of Haskell bolted onto the imperative language of C#, and in C#, brackets mean grouping like they do in Rust, but in the Haskell language, the brackets form sets. So if you want to do a refactoring between imperative code and functional code, you have to remove or reinsert the brackets, but even better, you have to remove or reinsert the then keyword. I keep saying this, I'm glad people laugh, because I do think there is hard-won experience, this is an aside, sorry Sophia, that I do think there's hard-won experience in programming language design that we have gathered over the last 50 years. And would people using languages that they expect people to use please learn about it and actually apply it, or contract me to tell them what they're doing wrong at the very least?
What is the hard-won lesson that you're drawing attention to here?
Well, in this case, the hard-won lesson is don't overload brackets, don't have syntax where brackets interpretation is so different, and in one language, and in the name of Niklaus Wirth, do not have one if statement that has a then and one if statement that doesn't. I mean, let me just say that again. In the name of Nicolaus Wirth, do not have one if statement that does not have a then and one if statement that does. Sorry, one of them is an expression. One of them is an expression. Sorry, Sophia. It's like the Dijkstra quote, but I think Sophia is now hiding in the camera. You know, there's a great quote about Dijkstra, which, when you do something dodgy, I want to imagine you're looking over the shoulder and thinking of Dijkstra. So this stuff is hard enough to understand, to pull it back to kind of the actual topic of the talk. This stuff is hard enough to understand, and this is just syntax. This is just syntactic, a lot of this shit. But this question we've seen in Rust about why can't I have a doubly linked list is more than just syntactic. It's to do with, well, it's what I call the heap model, or the effectively the semantics, not just of the code that I write, but of the heap structures, which I have to think about it that way, that my program may or may not build. I'm within friends. Can I do something daft at this point? I have a dream. This is a workshop, isn't it? Great, so you're not going to reject my papers just because I give bad talks, or, you know, the workshop demonstration collapses or something. So let's try this. I have a dream, and having used Dafny, here is basically a bit of my dream. Sorry.
It's a beautiful dream.
It's a beautiful, it's dream for me. I paid a lot of money to get Apple's user interface designers to dream that dream for me. And yeah, you know, it's like, it's beautiful, and can I even turn off mirroring or turn on mirroring, which will then break something else, won't it? Can you see a menu bar? Alt F1. I don't have an Alt key. Okay, I'm not sure that helped. Right, thank you. Sorry. I have a dream, and the dream is that I will be able to get a description of these things the dream is that I'll be able to get a description of these kind of things that I understand, these heap models, that if I'm a programmer, I'll be able to read and understand the actual descriptions. I mean, when I was growing up and I couldn't compile my Pascal or even my Smalltalk programs, I could actually go and look.
What's up? Are you trying to project something right now?
Kind of, yeah, but I just forgotten how to work my computer. But it's all right because people tried to help. And screen mirroring, mirror or extend to Paulina's MacBook Pro.
Can I see?
I don't know. I can just not do the demo. It's probably the right thing to do. Great! Okay, I have a dream. The dream is that my laptop will actually project properly on the screen. Okay, sorry. Yeah, apparently people editing the videos for SIGPlan like my talks, just saying, you can edit them down to about 5 minutes by leaving out all the comments. But anyway, great, this is my dream. We have this kind of thing where, you know, you can look at this sort of stuff. Here's, well, for Dala, this is in fact the heap model for Dala. Here's the important bit. Can some object f, the from object, have a pointer to the to object? And well, basically what it says is anything, if the to object is immutable, anything's allowed to point to it. If the from object is mutable, well, those mutables, because there's a hierarchy, are allowed to point to anything, but isolates can only point to other isolates and immutable objects. Is this the whole story? No. If people are looking puzzled, I'm happy to take questions, given how random it is, and you're all asleep after lunch anyway. For some reason, I always get scheduled after lunch. That's not true. Sometimes it's after morning tea. I do. Everyone was pulling a face, but anyway, okay, right. Yes? So Dala is the language that Kiko Fernandez-Reyes did, and there's a paper in Onward a few years ago about it, which is probably why somebody damned my European grant with the line, James Noble, he publishes in B-grade conferences. Yeah, that's right, because we had a graduate student do a prototype. Anyway, so you can find that if you look up Onward and me or Kiko Reyes. What I'm hoping to work towards is something that I used to call an object-oriented framework, but I probably have to think of some more Latinate phrase, like a conceptual ontology or something, for modeling these sort of heaps. Am I there yet? No, but I'm getting there. I might talk about that if I have a few more minutes. So Dala is the language I'm modeling. Technically, the name of the library or the framework, it's not really a library that I'm hoping to build, is Dahlia. Is this a joke about Iris? Yes. I'm not saying I don't think Iris is great. I think it is. I'm not sure I'm clever enough to use it, and I'm really certain that I won't be able to find programmers in the real world who want to understand Rust will be able to do it by looking at the kind of equations you need in something like Coq and Iris. I'm hoping, again, that possibly stuff like that is getting simple enough that people would be able to understand. Shall I go on? Yes. Mutable objects can have, that's a very good question. Actually, let's answer it. We can answer it. So let's look for, oh dear, is this working? Can anyone see a find box? Well, we can answer it, and this is something I'm hoping that it could actually happen by saying, let's try and find, okay, all immutables are immutable. Okay, so there are basically a couple of predicates here that control what evolutions a heap is able to go through, and this is one of them. It's valid too. This is basically the heap transition predicate, and it's saying one of the things there is all immutables are immutable, and if we keep on going, there's the definition of this. And what this says is for an immutable object, its field must always be the same. It can't change between each heap instant, each heap state. Okay? Mutable objects do not have that constraint. Can I find any other differences? Okay, initializing, we can't assign to immutable. Yeah, sorry. Right. Mutable and ISO. Okay, well in that case, I should be searching for the wrong thing. But I can probably still answer by doing this. ISOs, blah, blah, blah. Oh, that just tells us, gets all the ISOs. I knew I should have renamed this thing whole enchilada. Sorry, I haven't released it. If you're doing the artifact evaluation for eCube, I promise that I will rename. Actually, fuck it. No, I promise I will rename this by next week. What this says is for ISOs, just the ISOs takes a list of edges. I haven't talked about the structure of the model. At this point, it's basically 3 layers. And this says, get me all the ISOs, and then the constraint here is that the reference count for every isolated object is less than or equal to 1. Okay, you can have one pointer from a heap to an ISO. That's basically it. And I would hope that with sufficient English text and shit around it, I'm not in America, not in the Midwest, right, with sufficient English text and understanding around it, and in some sense we're seeing this in that the WASM specification, how legible it is, I don't know, is actually now part of, the formal specification of WASM is now actually part of the language definition. But I would hope that stuff expressed as simply as this could also be there. Can I really try and make a fool of myself now? What's the other part of my dream? My other part of my dream is that it's like, I was reading this obscure, well, it's not an obscure paper, but it's a paper that's probably popple obscure, from Uppsala in, I think, in 1991 about, this is terrible, bridges and encapsulation by John Hogue. Islands, of course. No object is an island. It's a great paper, and if you come from Popple and you haven't read it, you probably should, because I think we would have made more progress if Popple people had also read Uppsala papers. And islands is in some ways also one of these kinds of systems. Basically, the idea is we'll consider an object an island if it is separated from the rest of the program, pretty much in a separation logic sense, such that you can treat it as a black box. You can give horse specifications for its interface, and that those will actually be maintained by the program. And it effectively says it has 3 kinds of objects, well, 3 annotations, read, which I'm not going to touch, something called unique, which is pretty much the same as my ISO, and then it also has something else called free. And, okay, I can say, right, we're now also going to have objects that are free. What's the deal with a free object? Well, they're a bit like ISOs, except the idea, these are things, Could be an iterator, there could be the result of some long computation. The idea of a free object is you have an encapsulated object that creates this thing and returns it. So the deal of a free object is it's... why won't this verify? Can someone make this verify? If I do that, what's it doing? Yeah, okay. A free object is an object that has no incoming pointers. So my dream is that down here somewhere, I'm actually going to cheat and, where is it? Whole enchilada, isn't it? Oh, actually I could do it here. If nothing can point to it, then if we have a free object, if the to object is free, then nothing should be able to point to it, yeah? So I think if I do something like this, and I should probably say, yeah. Okay, I would like to do that, and now press the button. Don't you just love... and okay, that's actually validated it. And in fact, somewhere here I have a main method, and which effectively is testing a bunch of stuff, and I can say, okay, go back and re-verify that in Dafny. All right, and it dies. Great. Why does it die? I have an idea why it dies. Ha! Great. Who was it I said I was about to screw up the definition, but it wasn't going to end my career? Anyway, okay, it's because there was an example there. That is actually attempting to create 2 pointers into an ISO is what it was doing. Take that out. This thing should verify. Well, who knows if it'll verify. Whee, no problems. Okay, I'm going to take that as read. That has actually verified with the extra definition in. If we wanted to, we could now, well, in fact, because it's free, you can't actually add a field of an object and then assign it. Well, we could try that, and we could make a free object and then see again. Were we to do that, how do we do it? Var f4 is a new object, and it's free, and I'm just going to give it the same fields as any other object because I may as well. And now I can heap. So heap is a Dafny object that actually represents the reified heap. Fadd object, F4, there we go, we've added in a free object, and hopefully that should be okay. But if we, a few minutes, I have had already some questions, if we try and add in an assignment to it or something like that, as we've seen here, that would break. And if we change this and said, okay, look, let's assign that free object somewhere, in fact, this could break in several different ways. Why do that? It will fail to verify. If I point at it, it will actually tell me there is a precondition. The precondition is actually that it needs to be free. I didn't rehearse this very hard. If you saw me preparing the slides, I actually first did a dry run of this example just once at about 11 o'clock this morning. So that seems a lot less work than you would need with Lean or with other approaches to this. That's what I hope. What's the downside? Well, that's one of the slides that I haven't talked to is it's still Dafny. There was a great comment this morning in one of the talks. We didn't do this because it was hard. We did it because we thought it was easy. And that applies. And I have negotiated a fairly carefully chosen path through the simplest model that I've built. It's about 500 lines, non-commented lines of Dafny. And there was another talk earlier about using Dafny to do the type system for the CEDAR security policy language. And when someone said, what lesson would you learn? The answer was, well, don't do it in Dafny. Go to the main talk, and we've got a description of the formalization of this, what we did in Lean. And that was much easier than trying to fight with Dafny because What I haven't shown you is when it works, and when it doesn't work, well, it just doesn't work. And yeah, psychologically, the notion of an intermittent reward, which is you keep doing something and randomly you get a reward, is exploited by the gambling industry, by the computer games industry, effectively by drug dealers. Highly addictive. Social media works on that precise basis. You send a tweet saying that SPJ has just recanted on currying, and you get no retweets, and then you've got to give a bloody talk about Dafny. So Dafny, I think, also works on that sort of basis, that sometimes it will all go through like this, and then sometimes it won't. And if it doesn't, you have much less information about the reasons why it doesn't than you might like. That said, I'm really delighted in what this has done, in that I didn't actually have this error message and actually coming back and saying, we tried to do something with a free object, and the absolutely standard Dafny error message is we couldn't prove it wasn't free. That's pretty damn good. Yeah, I do have time for questions, I hope. A couple.
Yeah, let's thank James, and then we'll take a couple of questions.
So if I understand correctly, one point in the talk is that we can implement static policies as code in Dafny or some other similar tool.
Yep.
And then programmer would be able to play with them, understand them better, because they can see the code and they can reason about it in the usual way. It's running statically, but that's fine. Okay. But then my question is, when we use this sort of static discipline for memory ownership or any static discipline, pretty soon we need to add annotations on stuff that says, oh, this actually assumes this or provides this and so on. And it's very important in practice for the static checking to scale to modular programs. How does it work in your system? Can you just add post-condition and precondition that talk about your policies as you implement them? And would the users know how to do that?
The short answer is, of course, yes, maybe, and no. So because of the way these models work, although they're being checked statically by Dafny, they can be purely operational. If you don't, a dialer, because it's a gradual system, has a sort of mode of use where there are no static constraints. But we still want to know, okay, we're only allowed one pointer into an ISO, and it'll be enforced with dynamic checks. If you want more static assurance, then yes, you have to do annotations on your code. The way currently I'm doing it is you have annotations on effectively either your stack frames or the objects, and we statically check against those. So the preconditions for doing, say, that initialize operation is that we're sure there isn't a field there. The third question is, I think that in future we could finish the whole, well, at least do the left half of the picture, where this could go in underneath a traditional operational semantics or some kind of semantics of language model, a type system, and then you would prove that keeping this type system preserves the invariance that you want in the heap. But I haven't got all that connected up yet.
Hi, I was wondering, have you tried modeling borrowing and region type? How complicated does that become? Because ownership is the hardest thing you can do.
Yeah, so that's actually what I'm working on. Obviously, I'm hoping that I can be able to, for example, show the local ownership stuff that I talked about. The other thing with that is you're always just one lemma away from everything you do. So I'm very good. I've got something to show you.
All right, let's thank James again.